Mr. Wang He to the stage.
Distinguished guests, esteemed leaders from government, academia, and the industry of Korea, it's a great honor to speak at SBS D Forum today. I want to share with you a journey from the digital world of synthetic data to the physical reality of robotic deployment. This is the story of how we've been successfully industrializing embodied intelligence. My name is Wang He, and I'm the founder of Galbot and also a faculty member of Peking University. At Galbot, we are pioneering the future of robotics. Our mission is to develop generalist robots driven by embodied AI large models. Galbot is not just a robotic company. It's one of very few robotic unicorns that possess full-stack technology. Our unique technology of embodied AI large model, leveraging large scale of synthetic data, is what sets us apart and powers our breakthroughs. One great example would be this. At the World Humanoid Robot Games 2025, Galbot emerged as the only fully autonomous gold medalist in the live working challenge. While approximately 20 other teams relied on human teleoperation, our robot operated entirely on its own intelligence. And we outscored the second place team by a staggering 170 points. This wasn't just a victory, it was a validation of our AI large model. So what enabled this performance? It is our unmatched full-stack technology capabilities. We've built up the entire value chain from scalable synthetic data generation to our proprietary embodied AI large model, all the way to the hardware. Through a unique technology of synthetic data and sim-to-real paradigm, we've accumulated 10 billion embodied intelligence dataset, the largest in the world so far. We also set a high bar to our hardware. Every one of our humanoid robots will go through strictly quality control and meet the industrial grade and IP54 standard. This all give our robots the generalizability and the sustainable performance. I will start with introducing our AI and the AI model and the data. So as you may know, a promising approach to make robot general purpose is vision, language, action model. In short, VLA model. VLA models are embodied multimodal large language model, allow you to command the robot using natural language. It's simply like you just speak to the robot, please help me to pick up the apple, and the robot just do the work. So here, the VLA model will listen to your instruction and directly outputs the action commands that drive robots working. One biggest challenge that VLA approach faces is lack of data. We don't really have internet scale of robotic data. So here come our flagship VLA model, Grasp VLA, which is the world's first VLA large model pre-trained entirely on synthetic data. Synthetic data becomes the scalable and unlimited resource of embodied AI. Here, I visualize the billion-scale synthetic data that is behind Grasp VLA. The data covers all kinds of scenes and tasks with diverse object layout, environments, and language commands. training on this largest corpus of embodied AI model data, our model grasp VRA has achieved what we call the 7 gold standards of robotic manipulation: generalization across different illuminations, backgrounds, positions, object categories, and maintain robustness under dynamic perturbation and out-of-distribution cases. This proves to the world that synthetic data is not a compromise. Instead, it is a scalable and more efficient path to robust real-world performance. Not just the pick and place, we're applying this principle to solve some of the most challenging and complex tasks in robotics. For long horizon tasks, we generated a billion-scale synthetic dataset for folding clothes of different textures. This also helped our robot to do laundry. And building on this massive data foundation, we recently released the world's first bimanual VLA large model for grocery manipulation. Imagine a robot that can recognize and pick up over thousands of different grocery items, and even use both hands simultaneously to handle 2 different items. This brings unprecedented efficiency to tasks in logistics, retail, and our future homes. Intelligence is not just in the hands, it's also in the feet. We recently released the Naviform, which is the world's first cross-embodiment, multitask, map-enabled navigation foundation model for long-range autonomy developed by Galbot team. With Naviform, you can see this model output the future trajectory of how a robot dog should move. By this, our robot dog can autonomously deliver items using a map in outdoor environment. It can also navigate with extreme precision, avoid obstacles as tiny as 2 centimeters. It can even perceive and avoid transparent obstacles like glass doors. Crucially, Naviform is cross-embodiment. The same core model can be deployed on drones, humanoid robots, and robot dogs, dramatically accelerating development across the entire field of mobile robotics. Maybe people might not be so satisfactory about just driving humanoid-like cars, so we also care about legs. For humanoid whole-body control, we develop Any2Track, a whole-body motion tracking system. It enables our robots to learn and track any kinds of complicated human motions in just a few days, demonstrating best interior robustness to resist disturbance and maintain stable performance. Beyond the motion, we have Dext NDM, a groundbreaking dexterous neurodynamics model, which we can show in the next page. So intelligence is also not just in feet, it's also about hand. Unlike traditional trajectory programming, it uses a learning-based approach, enabling dexterous hands to flexibly rotate and manipulate complex irregular objects, including all kinds of tools like screwdrivers. And in the next page, we will see this model can actually operate very challenging objects, including very long objects or tiny atoms, achieving arbitrary orientation and precise handling. Yeah, so the video can show it. So based on our stable technology, our robots are ready deployed at scale in various scenarios. So the next slide, we will see at a Mercedes-Benz factory, our robots perform automatic quality inspection on sunroof assembly lines. And this quality inspection is purely based on visual perception. So the robot can understand what is happening in a runway and correct placement errors in real time. At a Zeekr auto plant, our robots are depalletizing and handling bins, fully autonomously planned by our AI large model without any markers on the bin or on the ground. The robot autonomously selects the nearest bin and optimal paths. Besides, we have established large-scale industrial collaborations with leading manufacturers such as CATL and Bosch Group. Galbot is among the first to embed the powerful NVIDIA Jetson Thor chip early this August. This live demo showed that our robot smoothly carries box despite deliberate human interference. It can still complete the task autonomously by auto-planning. And also in smart warehouse, our robot provides goods sorting. In a compact 30-meter squared warehouse. And you can go to the next slides. In a compact 30-meter squared, sorry, the previous one. In a compact 30-meter squared warehouse, they can identify and accurately sort up to 5,000 different items. And the robot providing 24/7 service in such kind of smart warehouse continuously for over 11 months. And this video show that our robot has also been deployed in retail scenarios. Right now, we have deployed our robot in more than 10 cities. In the last 3 months, there are more than 30 Galbot retail stores opened in China, many cities, including Beijing, Shanghai, Shenzhen, Hangzhou, etc. And we can go to the next slide to see. So our robot is actually helping people in healthcare center. And right now, our robot is helping the people to do pre-screening. They can provide services in nursing homes. They autonomously conduct assessment for cognitive function, grip strength, and vision, offering valuable data for early intervention while safely guarding seniors' privacy. Okay, I'm gonna draw the conclusion. Ladies and gentlemen, the age of embodied intelligence is arriving. It has moved from labs to industrialization. At Galbot, we are building the foundational models and full-stack technology to make general-purpose robots a reality. This journey from synthetic data to physical deployment is unlocking the new levels of automation, productivity, and assistance. We believe this technology will transform industries from manufacturing and logistics here in Korea to homes around the world. We are excited about the potential for collaboration with Korea's brilliant minds in academia and industry leaders. Thank you.